Okay, so good day. So we are now on quarter 2, module 1 of mathematics 10. Illustrate polynomial function, describe and interpret the graph of polynomial functions with the code M10EL IIA-B-1 and solve problem involving polynomial function with the code M10EL-IIB-2. So this time we are going to discuss only the first topic, illustrate polynomial function, describe and interpret the graphs of polynomial functions. Okay, so sa part 2 na lang yung solve problems. So what are our objectives? So we have illustrate polynomial functions, describe and interpret the graphs of polynomial functions, and draw the graph of polynomial function. In your previous lessons, you have learned that a polynomial expression p of x is an expression of the form of a sub n x to the n plus a sub n minus 1 times x to the n minus 1 plus a sub n minus 2 times x to the n minus 2 plus and so on up to a sub 0 where a sub n is not equal to 0. So this a sub n times x to the n is your leading term and this a sub 0 is our constant term. So for example, we have this 3x to the 4th power plus 5x cubed minus 7x squared plus 6x plus 8. So our leading term now is 3x to the 4 and the leading coefficient is 3, and our constant term is positive 8. So the leading term is the term with the highest exponent, and the numerical coefficient of that is the leading coefficient. So the leading coefficient of this example is 3, and the constant term is the term with x to the 0 or x to the 0, or a term without a variable x, because x to the 0 is also equal to 1. So in the other term, so we call that 3x to the 4th power as the quartic term, and that 5x cubed is the cubic term, and negative 7x squared is the quadratic term, and that 6x is the linear term, and of course that 8 is the constant term. So what do you call of the term with highest than 4, with exponent highest than 4? So we have that ax cubed can be called quintic term. We have ax to the 6 is fixic term, a to the 7 is fiftic term, and a to the 8, ax to the 8 is octic term, and then ax to the 9 is nonic term, and ax to the 10 is basic term, from the word decade, d. Okay. Okay, so the degree of polynomials. So how to determine the degree of polynomials? So it is referred to the highest exponent of the given polynomial. So that is the simple definition of degree of polynomial. For example, we have that 3x to the 4th power plus 5x cubed minus 7x squared plus 6x plus 8. So therefore, the highest exponent is 4, so it is on the 4th degree polynomial or degree 4. So another example, we have 8x cubed minus 3x squared plus 5x plus 6. So the highest exponent is 3, so it is 3rd degree polynomial or degree 3. Then we have that x to the 7 plus 8x cubed minus 3x squared plus 5x plus 6. Therefore, it is on the 7th degree polynomial or degree 7. And this time, how to determine if the given expression is polynomial or not. So we have these 10 given expressions. So the only polynomial of these 10 expressions are number 1, number 2, number 6, and number 8. So number 1, it is a linear polynomial, okay, where the leading coefficient is negative 6. And in number 2, it is also a linear polynomial because of the highest exponent is 1. Okay, and the leading term is x. The leading coefficient is 1. And the constant term is negative 4 because 2 to the 2 is 4. So that is negative 4. Number 6 is quadratic polynomial because the highest degree is 2. So negative 10x squared plus 1. So the leading coefficient of this given is negative 10x squared. And the leading term is negative 10x squared, and the leading coefficient is negative 10. And the constant term is 1. Number 6 is also a quadratic polynomial where the leading term is 6x squared, the leading coefficient is 6, and the constant term is 8. And this x is the linear term. Okay, why is it number 3 is not polynomial? Because of this 5x squared under the denominator. So there is a radical or there is a variable under the denominator. So therefore it is not polynomial. So in number 4, if you notice, we have 2 pi. So it's just a mere real numbers. So 2 times 3.14 16. While number 5, it is not also polynomial because of 3x under the radical sign. And if the expression has a variable under the radical sign, so it is not polynomial. And on number 7, it's not polynomial because of the negative exponent of x, negative 4, no? X to the negative 4 is not polynomial. Number 9 is not also polynomial because of the rational exponent. So if the expression has a rational exponent after simplifying into lowest term, it's not polynomial. And then number 10 is not also polynomial because of the exponent is radical. So it depends on the given. For example, that is 6x to the square root of 4. So it is already polynomial because we can simplify square root of 4 as 2. So before you decide, see to it that the given expression is on simplified form. So the next topic is how to draw the graph of polynomial function. So we have the example of the graph. Okay. So we have p of x equals to x cubed minus 2x squared minus 8x. So it has three terms, no? Okay, so x cubed minus 2x squared minus 8x, wala siyang constant term. So it is therefore a polynomial of degree 3 because of the highest exponent is 3. So polynomial of degree 3, the highest exponent is 3, and the leading term is x cubed. And the problem now is how to draw the graph of polynomial function. So we have the following steps. Step 1 is to find the complete factor. So I would like to emphasize that not all polynomial functions are factorable. So I will focus now to a polynomial function which is factorable. So if not factorable, so just assign value of x and solve for y or p of x, then sketch all or plot all the points and sketch the graph. So that is step 1, find the complete factor. We will give an example for that later on. Step 2, determine the roots or the zeros of polynomial x. Okay, so what are the roots and the zeros? So the zeros means it is the zero of all the factors of polynomial. So just equate to 0. Okay, and that's our the zeros. Number 3, draw the table of values, leaving space before, between, and after the zeros. We will illustrate later on, step by step. And we have step 4, solve for p of x given the value of x using synthetic division. And we have this step 5, prepare the Cartesian coordinate plane, so the x and the y axis. And step 6, plot the points. And step 7, sketch and describe the graph. So we have to remember also that polynomial p of x has at most n minus 1 number of turning points. That n is referred to the degree of polynomial. So if it is on the third degree, so it means it has at most 2 turning points. What do you mean by at most? Equal or distant or equal. So the x cubed polynomial has 2 or less turning points. Pwedeng isa, pwedeng dalawa. So turning points are points where the graph changes its direction. Gaya ng pinakita natin kanina. So the polynomial p of x has at most n number of roots or zeros. So what do you mean by this? So in terms of zeros, if we have x cubed or 3 as the degree of polynomial, so it has at most 3 roots. Okay, at most 3 roots, so it can be 3 roots, 2 roots, or 1 root. So the roots or zeros of polynomial is or are the points where the graph intersect the x-axis, just like we have illustrated before. Okay, so in this graph, so the graph comes down from the extreme left and goes up to the extreme right. So that are the zeros of polynomial. So in negative 5, I think this is negative 1.5, 0, and 3. Okay. So let us now follow the step to draw the graph of this given polynomial. So for example, we have polynomial p of x equals to x cubed plus 8x squared plus 11x minus 20. So we have step 1, find the complete factor. Okay, so using synthetic division, so we find the factor. So to find the factor, that as we have discussed earlier before, so we determine, we use the trial and error method. We try all the possible factor of negative 20. So we try 1, so the remainder is 0, and so therefore the first factor is x minus 1. This is the remaining quotient, so x squared minus 9x plus 20. Okay, so and then we try negative 4 from this remaining quotient. So the remainder is also 0. And therefore, if the first factor is x minus 1, the second factor is x plus 4. And the remaining quotient is x plus 5. And this is not factorable anymore. So these three factors are the basis for our zeros. We just equate that complete factor into 0. Okay, so determine the zeros. So just equate the factors 0 and solve for x. So we have now x equals to 1, x equals to negative 4, and x equals to negative 5. So it means that these are the zeros of the graph of this given p of x. So the graph will cross at the x-axis at negative 5, negative 4, and positive 1. Next step. So draw the table of values, leaving space before, between, and after the zeros. So we have that table of values. We have on the upper row is x, sa baba is p of x, or this is the value of y. So we assign first all the zeros, leaving space before, between, and after. So before negative 5 is, by the way, we automatically the value of p of x of that is 0. So this, because this is the zeros of polynomial or the roots. So negative 5, negative 4, and positive 1. Then we assign negative 6 before negative 5, negative 4.5 or negative 9 over 2 between negative 5 and negative 4. And we have negative 3, negative 2, negative 1, and 0 between negative 4 and 1, and 2 after positive 1. Okay. Then solve for p of x given the value of x using scientific division. Okay, so we have that given now. Let's solve using scientific division if x equals to negative 6. So this time we will use the given p of x. So if x is negative 6, so bring down 1. So 1 times negative 6 using scientific division. So this is positive 2, negative 12, negative 1, negative 6 times negative 1 is positive 6. So the remainder is 18. So therefore the value of y is negative 18 for that given value of x, which is negative 6. Then if x is negative 9 over 2, so we have this illustration. So 1, so negative 9 over 2 times 1 is negative 9 over 2. So added by positive 8, so it is 7 over 2. Again multiply, negative 9 times 7 is negative 63 over 2 times 2 is 4. Added by positive 11, so the sum is negative 19 over 4. Then multiply again, negative 9 times negative 19 is positive 171 over 2 times 4 is 8. Added by negative 20, so it is 11 over 8, or equals to 1.375 in this one. So you can use 1.3 or 1.4 as the value of y if x is negative 9 over 2 or negative 4.5. So if x is negative 3, so the remainder is negative 8. So from the remainder theorem, that is the value of the p of negative 3. Negative 8. So if negative 2, so we have negative 18. If negative 1, we have negative 24. If 0, it is automatically negative 20, because if we assign 0 in all x of this given, so the remaining is the constant term, which is negative 20. And for positive 2, the remainder is 42. Okay, so that is step 4. So we have step 5. Prepare the Cartesian coordinate plane. So, yun ang step 5. So we have the x and y axis. And then after that is step 6. We plot and draw the graph and describe the graph. Okay, so we have now this prepared Cartesian coordinate plane. So we have the y-axis and the x-axis, where the x-axis is assigned by 1 to its numbered line, and the y-axis assigned by 5 to its numbered line. So we have now the given, or the values, table of values of the given p of x equals to x cubed plus 8x squared plus 11x minus 20. So the first points to plot are the zeros. So let's plot first all the zeros of the given polynomial p of x. So we have negative 5, then we have negative 4, and positive 1. Okay, so this is now the zeros, the three zeros of p of x. Okay, and then if we have negative 6, let's plot now the other points. If we have negative 6, we have negative 18, so approximately this point. If negative 4.5 or negative 9 over 2 is 1.4 or 1.3. If negative 3, we have negative 8, approximately at this point. If negative 2, we have negative 18. Negative 1, we have negative 24. Negative 1, aligned to negative 1 and negative 24. If 0 is negative 20. And then for the 2, which is the value of y is 42, then our graph is limited up to 25 only. So do not plot the points yet, but we know already that the graph goes up to the extreme right. Then after that, assign the set of ordered pair of the given. So this is now your negative 6, 18. This is your 5 and 0. This is negative 4.5 and 1.3 or 1.4. And this is your negative 4 and 0. This one is 3 and negative 8. 3 and negative 8. And this is negative 2 and negative 1. This is your negative 2, negative 18 rather. This is your negative 1 and negative 24. This is your 0 and negative 20. Ito, kita. And this is 1 and 0. Okay. Then we're going now to plot or connect the points using a smooth curve. Okay. So let's connect now. So from negative 6, so minsan natin ibang block. So from negative 6 goes up. Then smooth curve, hindi yung straight line. Tama. Okay. So this is now the graph of p of x equals to x cubed plus 8x squared plus 11x minus 20. So the graph is comes up from the extreme left. Comes up from the extreme left and goes up to the extreme right. So that's how to draw the graph of polynomial. Hindi lang masyado maganda yung graph, no? Kasi nga, limited yung materials natin. Okay? Since we do not plot the points of 2 and negative or positive 42, so we just assume that this graph goes up to 42 and so on. So the graph of polynomial functions are infinite, so because it is still continuous downward and this is upward. So that's how to do the graph of polynomial function.
Hanggang dito na lamang po. Sana naman may natutunan kayo sa ating munting pag-aaral tungkol sa topic na ito. Hanggang sa muli!